Hello, this is Mike Lively, and this is Professional Papervision, and today we're going to talk about z-sorting. And it's a very important issue since in Flash 10 you don't have any z-sorting, you have to create your own. And we'll probably have one or two videos on this. Just one point too, there is a mechanism called iLayout that we'll talk about earlier where you do have automatic z-sorting, but for typical Papervision programming and taking that into Flash 10, we'll have to create our own z-sorts. So let's get started. What we're looking at right here basically is the torus worm that we worked with last time, and we want to discuss why it's not z-sorting first. If you watch the tip of this worm as it moves, it never faces you. Let me just freeze that real quick so you can see it. So it's always facing away from you as it goes through its iterations. And so that's not what you want. You actually want it to face toward you, which would signify it actually going around the torus as opposed to zigzagging back and forth. Let's see if we can make that happen real quick. We're in Adobe Flash CS4, and this is the torus worm code that we looked at last time. And I have a number of z-sorting algorithms I've added to it, and we're going to just use one of them real quick to get some z-sorting. Here's one. And we'll actually go through these and discuss each one of them. There's actually more than one way to z-sort. Actually, there's many, and it's important that you understand how they work. So let's save this, and let's control test and show you how it's z-sorting. And so if you watch your torus worm now, the tip of the head is going away and toward you, which makes it look like it's actually circling the torus. Now, there's a lot of this flashing going on, and that's because they have multiple colors, and it's reordering. So let's just set it to one color so it looks a lot different, and you can actually see the z-sorting a lot better. So let's reset the color. I'm going to go back to the code. I'll turn this off. Let's go up in the code where the color is being made. Here it is right here. It's basically being randomly set. I'm going to have comment this out. I've already done it here. I'm going to recomment this. And you can see here I'm just assigning blue. That's Roy G. Biv for each one of these little bits here. So you got FF will give you a total blue. So let's run that now. And so now you don't have the annoying flashing, and since it's all blue, it's just resorting. And you can see there's basically the head's coming toward you and away from you, and it actually looks like it's now circling the torus. And so that's a good thing. And let's now discuss how this is done. Let's start off this discussion by actually looking at an Adobe example. And so if you go to Quick Start Guide, Programming with ActionScript 3, let me bring the URL down here so you can see it. So here's the URL. And under Display Programming, we're going to take a look at one of their examples. Let's scroll down. And here's an example where we're actually going to work with swapping and the child index. So let's go ahead and go to the code and show you how it works. On the stage here we have 4 buttons you can click. Move to the back, move backwards, move forward, and move to front. Let's see what those do. When you run the program, you have a number of images on the stage, and when you click one, depending on what you've chosen in this list here, it'll do that. So if we click Move Back, click that, it moves it all the way to the back. Or if we click Move Front, it'll move that display object all the way to the front. Now moving backward actually moves it back a child every time you click on it to get to the back. And moving forward, move it forward a child every time you click on it. Let's take a look at the code and see how this is done. In the first part of the code, we actually define a container, a sprite container that we're going to put all our objects into, and we're going to order inside that container. So once you create a container that you can put all your objects in, you need to bring those objects to the stage. Now we've done this before, and basically what you do is you create all your objects in the library, and you give them a linkage name. Go to Properties here, for example, the red circle. We have a linkage name of red circle. So hit OK. And you can see for the red circle, we actually just go red circle, we declare it, and then we give it an instance name red circle, and then we place it on the stage and we add it to the container sprite. And we do this for a green square, a blue triangle, a yellow circle, and a purple square. And all those should add basically from down up. So if you take a look at the program, we can basically see that you have display lists for the container sprite. And the first one you added was the red circle, which is on the bottom, then the green square, the blue triangle, the yellow circle, and the purple square. And in Flash programming, and basically in Papervison3D in Flash 10, you're going to need to basically order these objects based upon their Z position. So that's the whole trick here. But you'll use all this same programming, for example, setting index and swapping children and so forth. So let's go on a little bit further and see how the rest of the code was created. So we take those instance names that we created, and we add a listener, and that's the mouse click listener. And when we click on the object, we run the shape click handler method. Now let's take a look at the shape click handler method. This method has a series of if and else if statements in it, which correspond to the different selections that you would make. For example, move back if that's selected, or move backward, move forward, or move to front. So these four options allow you to move your object around. When you select those, essentially what you do is you call that particular method. So as you can see from the diagram, here's your move back, and you move backward, and you move forward, and you move to front. So by selecting those different options, you actually cause these different methods to be fired. Let's take a look at each of those methods. So the move to back method basically uses the set index to set the index of the clicked on shape to 0, which moves it to the very back, since the smallest number is essentially on the bottom. So the way the move backward method works is the first thing you do is you get the child index of the shape you clicked on. And then you subtract 1 to find out what its destination should be, because you're going to move it back. And then what you do is you get the name of the child at that index right here. And then you use the swap child method to switch your shape that you clicked on with that destination name. Swap child is really an interesting method, and we'll show you how to use that with the torus worm. The other two methods follow in the same way, but just reverse. In the move forward, you pretty much just add 1 to the present index, and you want to make sure, of course, that that's not the last index, and then you swap with the higher index name. So that's pretty easy. And the final one is move to front, and the move to front, of course, is the number of children minus 1, because you're using a matrix that starts with 0, and you just take your shape and you move it to that level using the set index. So both set index and swap children are powerful methods, and we'll use those in code to come. So from this discussion, what you should get is that there is a display list, and that display list is an array. And so to work with zSorting, you need to basically change the order of that array. And I put this document together. I'll include it with the download of the code, which talks about sorting and arrays and children and everything you need to know when it comes to zSorting. So you're going to sort arrays in many different ways, based upon case sensitive, based upon descending or descending, based upon numeric, and we'll use these in our zSorting algorithms. Number of methods that you can use: reverse, sort, sort on, update, and basically here's a whole string of examples that you want to go through when you download the doc. And then there's a whole little, once again, a reiteration of display object programming. You want to make sure you go read through that again. Very important that you understand how display objects work and how to add objects to a display list. And we have this example that we just went through. So also in this document, I have listed a number of important methods that you'll use throughout your programming of the display object list, and that's add child at, get child by name, get child index, remove child at, set child index. Very important that you'll learn how to work with that. Swap child at, swap child. I just want to say something very important. So why do you need all these methods? Well, here's the key. As mentioned previously, the layering order of display objects in the display list determines the display layering order, regardless of their relative z-axis. If your animation transforms the properties of a display list objects into an order that differs from the display list order, the viewer may see, or will see, by the way, objects layering that does not correspond to z-axis layering. So an object that should appear further away from the viewer might appear in front of an object that is closer to the viewer. So you have to use these methods, in a sense, to reorder your display list. At this point, I'll just leave this document as an exercise for you to read through, and we'll go to our torus worm and order it using some of these methods that we've discussed.